in this Python sequences, so the objective here is to familiarize object and generate a sequence. We will also review sequence and iteration along with their basic operation. So we will review indexing, slicing, membership, concatenation, length, getting the length of a sequence, iteration, summation, unpacking, repetition, and sorting. So these are the common operations that you could perform on a particular sequence. We will also apply the aforementioned operations in string, list, and tuple. So there are other sequences like byte arrays, but for the purpose of simplicity, we will only focus on lists, tuples, and string. We will also create functions with parameters and return values. So to begin with, collection of objects. So this is not similar to a set in mathematics where you don't have a particular order or you don't support repetitions. So a sequence, you could collect the a specific sequence usually indexed with, and the last element would be the number of items minus 1. So 0 to n minus 1. Definition of a sequence, which we could apply to a list in Python, string, and also tuples. So to begin, let's review range object. We have familiarized with range object in the first meeting. But right now we could dig deeper on how to create sequences using the range object. So for the range object, this is the format. If you call the range object, you need a starting number, an integer, stop, or you could also put a step. Okay, so the only number required here is the start. So you could set the default or the default stop to the number that is given. So for example, if I have, okay, let me just print something. If I have a range from 0 to 5, I could set it to 5, and this default value will be the ending number. So this will be the end, but the default start is 0. Okay, and then the end number, just remember that this is exclusive. So that means it will not be included in the sequence. So the sequence that will be produced here will be from 0, 1, 2, 3, and 4. So the fifth element, which is supposed to be the upper limit, is not included here. But you could count the number of elements here will be equal to 5. So 5 could represent the number of elements if you start it by default as 0. Let's try to print this one. And the way to print this is to use the pattern, the for pattern. So for the number in this particular range, you are going to print the number, and it should print 0 to 4. Okay. So as you could see, it printed 0 to 4. 0 to 4. Now, you might ask, why do we need to put it in an iteration, like in a for loop? So if you go directly with the just the range, if we just go with the range, okay, it will basically not put or not print the sequence. And if you check the type range 5, it will simply give you an object which is a range. Because after all, a range is not a list. So it will not give you a list of numbers. It will not give you a tuple of numbers. It will return to you an object. And this object can generate a sequence, but it is not equal to a list. So you could compare that with a list later on, and you will see that they are different. So a range object returns an object that produces a sequence of integers from start inclusive to stop exclusive. So that's what you have to remember, that the ending part is exclusive. So the pattern earlier, if you really want to make it explicit, uh, you could put a starting point here, 0, and a step which is 1. But as we have seen earlier, this starting point which is 0 and a step which is 1, it's already the default value. So step 1, it will just implement the same numbers. So it will just implement the same numbers. And you have 0, 1, 2, 3, and 4. So after this, let's solve the drill. So using both while iteration and range object, generate the following. So you have a sequence of integers 1 to 10, and generate a sequence of even integers 1 to 10 as well, and add integers 1 to 10, and you have a sequence of integers 10 to 1, so reversed in this case. You could easily generate this with a range, but before that we could also generate it with a while loop. So we have familiarized ourselves with while loop before. So what you could do with a while loop here, we could start with, for example, while, and let's initialize a certain variable. Say I have a counter, so let me name it count. So I will set it to initial 1. So while count is less than or equals to 10, which is my upper limit, then I could simply print the count and make sure to update the count here with a 1. And if we do this, okay, it will give us a 1 to 10 sequence. Okay, so this prints out 1 and then 2 and then 3 up to 10. So that's a sequence of integers. A sequence of even integers, well, so this is for a sequence. So you could have a sequence of integers or even integers from 1 to 10 as well, or within the range of 1 to 10. So you could use the same principle. So in this case, I'm going to have a count. So let me start the count with 1, and while. count is less than 10, so you could print the count. Okay, but the increment here, so if this is even, you could start with 2 and let's just print the number and let's increment the count with 2. So in this case, we will update in 8, 10. So that's a sequence of even integers. Add integers as well, okay, using the while loop. So using the same principle, sequence of add integers. So the initial counter will start here with 1, and while the count is less than 1, printing the count. And in this case, this variable will be incremented by 2 as well. So we're expecting this to print 1, 3, 5, 7, and up to 9. Okay, and it did 1, 3, 5, 7, 9. So that's the way of printing odd numbers in this case. You could also try modulo if you like. An alternative approach will be to check whether the number, so the count will simply be incremented by 1, and then you could have a condition here if the modulo is greater than 0. So if count modulo 2, if that is true, then you have to print count. So if we run this will also 3579. So you could say that this is an alternative solution. Alternative. Okay, so lastly, to printing the odd numbers, you could also print the integers 10 to 1. And in that case, you could, in a while loop, you could start with the initial gradually decrease it. So the count is less, or in this case, while count is greater or equals to 1, we will decrement the count. So count, okay, and the expected here, we're expecting it to provide us with 10 to 1. Okay, and it did. So 10, 9, 8, 6, 5, 4, 3, 2, 1. Okay, now let's try to solve these problems with, so we have already done them using while iteration. So if you're using the object, oh, using while. Okay, using the range object. So if you're using the range object here, sequence of integers from 1 to 10, you could easily use the for loop pattern here. So for I in range, and in this case, since the last element here, the upper limit or the end is exclusive, so you have to add 1, or you could use 11 instead if you want to print number 10. And in this case, since the default is 0, so you could put a starting number, which is 1, to override the default. And you could just print the I. So you don't need to increment I because this is a for loop. So this range of this will already produce the 1 to 10 number. So control B. And the expected output is 1 to 10. And what we got is 1 to 10 as well. So this is using the range object for 1 to 10. In the same manner, if you have even integers, so a sequence of even integers, so a sequence of even integers from 1 to 10, you could come up with another for loop, I in range 10 plus 1, or you could immediately uh, write 11, and we could come up with a step. So if this is even integers, we will start at 2, and the step is also 2. So this will skip one place, so it will be 2, 4, 6, 8 up to 10. So if you print the number, what we will expect here is 2, 4, 6, 8, 10. And it did provide us those numbers, so 2, 4, 6, 8, 10. Next problem will be the odd numbers or the odd integers. So if we're using the odd integers, so we could generate the same pattern, but in this case, we would start with 1. Okay, same step, which is 2. And if we print this, it will give us 1, 3, 5, 7, 9. And it did. So that's the sequence of integers. Just remember the pattern here. This one is the start included in the sequence. This is the end or the upper limit. And take note that this is exclusive, meaning that this 11 will not be included in the final sequence. And lastly, this one is your step. Okay, so I hope that's clear. And the output is also clear. So for reversing the sequence, in while loop, we could easily, if you remember in while loop, we could easily start with a higher count, like 10. But in using the range object, okay, you could do reversing by having a negative step. So let's copy this. So a sequence of integers. So you have, so for I in a range, so you will start at 10. and you will go to 1, which is 1 minus 1, or to 0. Remember that the upper limit is exclusive, and then let's subtract it by 1. So this will be our step. So negative step means decreasing. This will be our start, and this will be our end, which is exclusive. So I expect that it will not include 0, so it will just continue up to 1. So this will be printed. Okay, let's print I, and what value do we expect? So it will produce 10, 9 up to 1. So control B. Wait. Okay, let's control B here. And it's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that's what we expected, and that is what we got. You could also use the reversed method in Python. So you could still count with the initial increment. Okay, like for I in range. So you have 1 to 10 plus 1, for example, and the default is 1. But you could reverse it with the reverse method. So reversed, and this reversed method will reverse your sequence. So if you print now your I, our expectation here is it will be reversed. So it will be from the initial 1 to 10 increasing, it will be reversed, and it will be 10, 9, and up to 1. So let's run this. Okay, and it's reversed. So this is an alternative. So this will be alternative method for the reversed. Okay, pretty much that's it. If you want to investigate reversed farther, you could simply issue the command help and then reverse. So reversed method returns a reverse iterator over the values of a given sequence. Okay, just issue the command help and then the name of the function. So that's for the reversed. Okay, you could also have a return. So the context of a return is it will be utilized if you have a function. So remember before, when we declared a function, I emphasized that you have two parts. If you declare a function, you have the definition, and after that you have the function call. So if you define the function like define a greet function, and all I have to do is just to print something. Okay, print hello, for example, and after this will be executed. So if you run this as simple as this will not execute the print. So if you run this, control P, this will not execute anything because this is just the definition. So remember that I emphasize that for you to run the function, you need a function call. And you call a function using the name. So in this case, if this is greet, defined as greet, so you call it by its name, greet, and you run it, and it will produce the print after running it, after calling it. Okay? So what does return tell us? Return is returning the sum, it will give you something. Like if I'm doing a function for sum, okay, so if I'm inputting two numbers, so maybe this is my first number, and then I have a second number, and then I want to, instead of printing the sum, of course I could print the sum. So print the sum. So if you have first number plus second number, I could do this. So this will be my function add, for example. And if I add two numbers, if I call this, so if I call the add two numbers with 10 and 20 being the arguments, so it should give me 30 because I'm printing the two numbers. So it will print 30. Control B. And it did print 30. But if I want to assign it to a value, like if I want to assign it as my initial sum, and I will use it later on, because if I assign this to a variable, and let's run this and printed the value of that variable, so let's print the value of that variable. We expected this, or at least beginners will expect that this will store the the result or the sum. So if you run this, it printed 30, and then it give you none. So this might be confusing to beginners. Okay, this might be confusing to beginners. Why is this none? Because in this case, there is no return to the function. So if you're not returning in a particular operation or function, then the default return is none or nothing. So in this case, since we are returning nothing, we cannot use it for further operations. Like for example, what if after getting the sum, you want, maybe there is a final sum that you're also computing, and you're utilizing the result of the previous operation. Maybe you're adding it to something, like maybe you're adding maybe 30 to it, and if you're printing the final sum, you might expect that this will become 30 plus 30, so final sum will become 60. Okay, but if you run this, then we will have an error, because you are operating here with an initial sum that is none or nothing, and you're adding it with 30. So if your process of computing is just a single process, like you're just adding two numbers, and then after that you're outputting the result, okay, then perhaps the printing is okay. You'll be able to show the result to the user. However, if your plan is to use the result, okay, like for example, you have a sum here, you have a sum, and actually you are planning it to another operation, okay, which is sum plus maybe another number like c. If you're doing multiple stages of computation, then you need to return the value that you are utilizing, or the value of the result for that particular method. So So that's for further process. So in this case, you could easily correct this error with a return. So in this case, we are returning the result. And after returning the result, so the initial sum here will be 30. And then the final sum will be 30 plus 30 will be 60. So it will no longer result with a non-type error. Okay, so let's run this. Very simple operation. So initial sum is 30. So that this is the first print. This gives you 30. 30. And the final sum will be the 30 plus 30, which gives you 60. And indeed, it gives you 60 here. So that's the purpose of a return. If you are trying to utilize the result to another process or to the next process. But if you're just having a single process and you're just trying to print something, then a return is not necessary. Okay, so that's the sample use case of a return. So take note that a return will already end the execution of the function. So that means if you have a return here, and after that you will have a print something, maybe print end of function. Okay, you have to take note that this will not be executed. So this will not be executed. And why is that? Because return will already exit. So this will terminate the function call your functions here. Okay, let's add two numbers. So let's call this add two numbers, and I will just add 1 and 2. And what it will do is it will call this definition, but it will skip the printing of the end of function. And the reason for that is you already have a return prior to that. Okay, prior to this command. So if I run this, it will it will simply do nothing actually, or it will just compute. So let's try to save it to a variable. So total is maybe what I will do is I will simply print the total, so we could see the result of the operation. But you will not see the printing of the end, the printing of the string. You will not see that. Okay, so let's run this. And indeed, the result is 3, but you did not see the print. Because as I've stated, and as stated here in the notes, the return will already end your function call. So what comes after the return will not be executed. Okay, however, if you put it before, okay, like in this case, this will be the start of the function. If you put it before, then that will be executed. So control B, and we will see that start of function is printed here. Okay, because it's prior to the return. So I hope we clarified the function here, or the return statement, which ends the execution of a function call and returns the result. Okay, so drill one. So again, turn you could pause the video and try this problem yourself. So using both while iteration and range object, create functions that generate. So in this case, this is very similar to the previous problem, but you are asked to create a function and then return the sequence. So, okay, it is a bit vague here because you're going to return a sequence. So that means that you are going to return the range. Or a list. So I will just clarify this one. So return okay, return a list. So we could print it. So return a list of each of the following. So the list is a sequence of characters, or it should be a sequence of objects that we have discussed in the first part of the refresher. So let's return a list. So the way to do this, okay, so you could try it yourself. But in my case, let's define a function here. Okay, so I hope you tried it yourself. So let's solve it together. So let me define a function and let's call it using both while and range. Okay, so I could reuse the while routine that we have utilized earlier. So this is my sequence of integers. So 1 to 10. Okay, this is my sequence 1 to 10. Okay, say I'll just call it using while loop. And let's just recall what we did earlier. So you have an initial count, which is equals to 10, or count is initially 1. And so if I'm going to return a list, so we will apply accumulation here. So list accumulation, if we're having a list, so we could start with an empty list. Say this will be my result, which is initially empty. And then while count is less than or equals to 10. So instead of printing, I want to return the result. So in that case, I will be utilizing one method of a list. So let's try to give a brief background of this method. Because I will be utilizing the append method. So this append method is actually built into a list, and it will simply add the object to the end of the list. So if we started with an empty list, then there will be no elements, and as we append the elements, it will be added to your list. So I could just say append, and I will append whatever count variable or count the integer that is produced, and afterwards let's increment the variable, and we need to return. Again, you could print if you like. So if you want to print for visualization, so okay, nothing is stopping you. But in this case, since we are required to return the sequence, we need to return the result. So returning the result will be our goal here. So if I print this sequence, if I call this function and run this, okay, it will print the numbers because we have a print. But if I mute the print or comment it out, it will do nothing, as you could see here. So it will do nothing because we did not print it. It basically creates the list or the sequence, and then it simply it simply puts it in your console. So it did not print it at all. It simply but for you to print it, okay, you need to issue the print command so that you have to print the list. So what we expect here is when the interpreter reads your function, it will go to the definition and execute this block of code. So count equals 1, result is blank, and then do this while loop. And then afterwards, return the list. So after returning the list, you are printing it here. So it will become a list of 1 up to 10. And indeed it is. So you have 1 up to 10. So we have successfully solved the first problem here. And the rest of the problem is very similar. So returns a sequence. Okay, returns a sequence of integers 1 to 10. So in this case, using while. Okay. If you're using range, this will be a bit, this will become very, very brief casting. So this will be using range 1 to 10 using range. And I will simply return the range object. So the range object, and that will be 1 to 10. Let's explore this for now. Currently, we are printing here a range object. So this will be range 1 to 10 or the list. So you could typecast the into a list. So as you can see, the change here is very drastic. So from 1, 2, 3, 4, 5, 6, from the 6 lines of code, we reduce it to a one-liner code for you to produce the sequence. Let's run this. and you have sequence 1, 2. This should supposed to be plus 1 because this is exclusive. The last number is exclusive, and it's 1 to 10. Okay, so that's how to return a sequence of numbers from 1 to 10, or a list of numbers. For even integers, so we have a similar approach. So I could say using while loop, return a sequence of even integers, and you could start with 2 here and accumulate, and let's just change the increment to 2 and return the result. So if we print the result, so we're expecting here a sequence like 2, 4, 6, 8, 10. Okay, so and we did get it. So let me comment the previous one to avoid interference. Okay, so you have 2, 4, 6, 8, and 10. And that is what we want. As expected, if you use range, okay, you can greatly reduce this routine. So using the range operator, so this will be range. This is no longer sequence. This is supposed to be even. So even sequence. And this is supposed to be even using range. So if I'm using range here, I will simply return the range object. And if this is even, so this is 2 up to 10 plus 1. And the increment will be 2. And for you to be able to see the list of numbers, you could typecast it into a list. Okay, so if we print this, you could easily see the result. Okay, which is this is just a one-liner function. Okay, so you have 2, 4, 6, 8, and 10. Same approach if you have an odd number. So for the odd number, so let's solve the odd number as well. Okay, 1 to 10 using the while loop. And you could start with 1, you could increment with 2, and then result. So result, so these are odd integers using while. And if we print this will give us 1357. So let's print this. So 13579. And indeed, it give us the sequence, the odd integers. So another approach will be the range approach. And in the range approach, we will simply have a one-liner code for you to return the sequence. So return the sequence, which is from 1 to 11, or 10 plus 1, and sequence or step will be 2. And that's it. So we expected this to be 135. Okay, and this is 1357. Okay, for our last drill, sequence of integers 10 to 1. So same drill. If you have a while loop, so sequence, okay, let's just use this one. So sequence from 10 to 1 using while loop. And if you're using while loop, you could easily start with 10. So count is initially 10, and while your count is, say, greater than 0 or greater or equals to 1, what you do is you could say return or result that append. So you accumulate the values of your count and you initialize your result. This could be optimized using list comprehension, which is we will discuss in the next refresher. So this will be appended and returned afterwards. Return the result. Okay, so you need to update our count or else we will end up with an infinite loop. So count minus equals 1. And let's print the result. So print the sequence. And what did we expect here, which it's a sequence 10 to 1. Okay, and indeed we got a sequence which is 10 to 1. But then again, if you use the range object, then you don't need this long counting. So if we're using the range object, then we will end up with a one-liner code. So using the range and returns a sequence of integers 1 to 10 using range. So using the range object, we will simply return a list of 10 up to 1 or up to 0 exclusive and negative 1, and pretty much that's it. So if we print the sequence range, okay, so we will expect 10 to 1. Wait, let me indent this one. So Control V. And indeed, we get 10 to 1 as our numbers. And that concludes the drill. We still have one more activity for this particular drill. So create a function that computes the sum and average of the sequence. So I will just create one function just to show that you could get a sum here. And the idea here is you could also use accumulation in a while loop. So way back in C, so if you're programming in C, a common pattern, okay, so you have sum of sequence, so compute sum. Okay, let me define this one as compute sum. Okay, and if I have the sequence, so I will not use it as a parameter yet, or we could use it as a parameter in this case. So I have here sequence, or okay, if you have okay, so the sequence, and what I could do here is I could just iterate the all of the elements of the sequence. So for item in the sequence, for now, let's try to print the values just for you to visualize. This is not yet doing anything. This is just printing. So if I have uh, my sequence, for example, my sequence is just 1 to 10. So I'll just come up with a 1 to 10 sequence and assign it to my sequence variable. And then I want to execute compute sum. This is supposed to compute the sum, but right now it's just printing the values. So if we run this, I expect to see the values like 1 to 10. Okay, sequence is not defined. So name sequence, sequence. For I in sequence. Okay, so the argument here should be my sequence. Okay, so what it did is simply prints the number, and then this sequence is just the decreasing number 10 to 1. Okay, what if I want to add these values? So I will simply have the usual method is to have an initial sum, or so initial total, and then just accumulate the total within your for loop. So total, okay, plus the element, okay, that we have printed. So in the first run here, let's just clarify this for beginners. In the first entry of the for loop, it will add 0. So when I is equals to 1, it will add 0 plus. So when I is equals to 0 initially, or when I is initially 10, 10, so it will add 0 plus 10, which will give you 10. And that is the current value of your total. When I is equals to 9, then it will be the current total, which is 10 plus 9. So it will become 19 in this case. So and so on. So when I is equals to 8, this will be the current total 19 plus 8. So it will become, in this case, 27, and so on. So this will accumulate the total of the series. So with that accumulation, let's just print the, let's return the sum, return the total. So this one computes the sum of the sequence elements in the sequence. Okay, computes the sum. And after computing the sum, we could just print the result. So print the sum. Okay, so what we expected here, mathematically, if we use the arithmetic progression formula, so first term are the number of terms, first term plus last term. So this is the the total of an arithmetic progression. So if you have 10 items, and the first term is, you could have 10, last term is 1. So in that case, you'll have, so 11 times 5. So you'll have 55 as a result. So we are expecting a sum here equals to 55. I'm just using the arithmetic progression formula. And let's run this code. Okay, and indeed, we got 55 result. Okay, here. So the sum is 55, which is consistent with our mathematical solution. Okay, so that's computing the sum. However, in Python, there's an easier method. You could simply use the sum function that is for sequences. So you could automatically use the sum function. Okay, let's try to examine it. If you have help and sum, okay. So the sum method returns the sum start value plus the iterable numbers. So it will total your numbers within the sequence or within the iterable data type. So in this case, instead of using my custom function, which is compute sum, okay, I could also use a sum method directly, which is available native to Python. So let me just use it. The method that is native to Python, which is the sum, and I will just compute the sum of my sequence earlier, and hopefully it will also give you 55. Okay, and in this case it's not defined, so let me rerun it. Okay, so my sequence will be the sequence from 10 to 1, and okay, let's run the code. Okay, and it still give you 55. But take note, we are no longer using the custom function which is commented out. We are using the built-in sum function in Python, okay, for sequences. Okay, so that's the idea about the computing the sum. And you have computing the mean as well, or the average. So in that case, you might already know where am I going here. So if I'm using the built-in methods in Python, so if I'm going to compute the average, like for example of the given sequence, the average of a given sequence. So I will simply return. So this computes, okay, returns the average or the mean of sequence elements. And what I will do is simply return first the sum of the sequence divided by the length. Okay, remember that you could also compute the length of a sequence using len function. And if you need to refresh that method, okay, just issue the command help and then len. So returns the number of items in a container. So for this particular scenario, you have the average. So let me utilize my sequence before. So if this is 10 to 1, what's the average here? 55 over 10, so 5.5. The average here is 5.5. So let's try to print the result here. Okay, print the average of my sequence. And we're expecting 5.5. Okay, 55 being the total divided by 10. So it should be 55 or 5.5. So let's run it. And indeed, the average is 5.5, the average of the sequence. So you could play with this if you like. You could think of a score like what is the average? Okay, average of maybe 80, 90, 65, and maybe 95. So in this case, you need to input a sequence. So input it as whether a list or a tuple later on. So in this case, we have seen that the average of this course is basically 82.5. And this is computed using our custom function earlier. Just one-liner code. Okay, you could get the sum using the native sum function and the length, which is also native to Python. So just a review, the list is basically a sequence, an enumerated collection of objects. So a list is mutable. That means you could change the items, and it could contain heterogeneous elements. So you could contain as it could contain a string and an integer at the same time. So if I have to demonstrate this, okay, if this is my list, okay, I could store uh, an integer, okay, maybe 10. I could store a floating point value, maybe 3.1416, okay, which is float. I could store string, okay, maybe a name and a boolean and so on. So I could store these elements as opposed to other arrays or other data structures in other languages, okay, in which the elements are homogeneous. So in a Python, you could have a heterogeneous list of items. So the order here matters. Okay, like you could have a specific first element. Like in this case, the first element in a list is designated with a particular index. So you have here an index 0 for the first element, and 1, and 2, and so on. And the last element will be, in this case, 3, which can be computed with n minus 1, n being the number of elements. So you could we could examine the data types here. Like you could investigate the data type for the first element, for example. So by virtue of indexing, you could call the first element and check the data type of 10, okay, which is we have already guessed, or we have already concluded earlier that this number, or the number 10, is an integer. Okay, so this should be type int. If you repeat this to the second element, which is 3.2426, this should be float. And the last, or the second to the last element, is a string, with the last element being a boolean data type, and so on. So a list can also contain another list or another any object. So you could put any object in a list. So for a particular sequence like a list, okay, you could perform basic sequence operations like you have indexing, slicing, membership, concatenation. You could get the length, could perform iteration, could have summation, unpacking. So summation is applicable to numeric values, okay? And repetition, okay, you could also do sorting. So feel free to try this yourself and explore using the interactive Python shell. You explore the possibilities. So like for example, we already created our list earlier, which is composed of 10, 3.2, name, and true. And we have started with indexing. I have already stated that the index, the index here, the index for the first element is 0, second element is 1, third element is 2, and in this case, the last element is 3. Okay, but there's more to it. There's also what we call in Python as negative indexing. And that negative indexing will start from the last element. So the last element is considered as negative 1. Second to the last element will be negative 2, and so on. So third to the last is negative 3, and fourth to the last is negative 4. So we could explore such indexing. So for example, if I want to print the true using the negative indexing, I will simply use the name with the bracket notation for signifying the indexing. So this should be the bracket notation for the indexing. So if you have already seen me use the positive index. So it starts with 0 as the first element. And then the last element here, 0, 1, 2, 3. So 3, which is true. If we use negative indexing, so we could use negative 1. That will be the last element as well. Okay, if I want to print the first element using negative indexing, all I have to do is to just count, okay, from the last. So negative 1, negative 2, negative 3, and negative 4. So if I want to print 10, I will just issue negative 4. And this is equals to 10. Okay, what if you move farther than that? Okay, like negative 5. So in that case, that is no longer allocated to your program. So if it's not allocated to your program, the index is out of range. Okay, even with the positive index, okay, like if you mistakenly use the index 4, okay, and you expect that there are 4 elements, remember that we started with 0. So 0, 1, 2, and 3. So 4 is already beyond the range of your list. And the interpreter, Python interpreter, will inform you that you are accessing an index which is out of range from what your program is declaring. So it's out of range. Pretty much that's it for the indexing. Okay, next is the slicing part. So we could go to your my list once again, and you could slice, like for example, what if I want the first and second element? So I could use the notation. So you have the still the bracket notation, okay, the name and then the bracket notation, and then upper limit and lower limit. Okay, from lower to upper, I mean. So this should be from lower to upper. Okay, so if I start from 0, I could go to 2. And take note that the second limit is always exclusive. So this one is exclusive. And remember that the meaning of exclusive is it will not be included. So if 10 here is my first element, and with index 0, the first element has index 0, and 3.2, the second element which has an index 1, and then the name here has index 2. So if I print my list, which is 0 to 2, then 2 will not be included. So it will just print 0 and 1, and what I will end up with will be 10 and 3.2426. So that's the output of this particular slicing. Okay, so if I slice the first two, okay, it's just two elements, not three, because remember that the index 2, which is the upper end, is exclusive. Okay, you could also have a default value, like if I remove 0, it will default to 0. So I will expect to get the same result. Okay, if I remove the lower and then the upper limit as well, okay, what I will get is just the original list. So in this case, original list from 0 to the last. Okay, or in this case, I could just start somewhere up to the end. So if I start with 2, okay, what do you expect here? Remember that, okay, this is index 0, index 1, index 2, and index 3. So if I have a slicing with 2 colon nothing, okay, the default here is, the default upper is until the end. Okay, and since until the end, it will start with 2. So this will be name and true. So the result that I'm expecting will be the string name followed by the boolean true. So this is the result that I'm expecting. So name and true. Okay, and indeed we got that particular result. So you could also play with your list, okay, by reversing the elements. So you could do that with, um, I think, with a step operator like -1. And -1 will be just telling your slicing that you try to reverse the order. So start to finish and then reverse the order. So in this case, we reverse the order from 10, 3.2, name, and true. Okay. The new order now is true, name, 3.2, and 10. So this is just one convenient method, okay, for reversing, doing a reverse sequence. So if I'm saying that it's reversing a sequence, okay, later on this will be applicable to a tuple. Okay, this will also be applicable to a string later on. Okay, that's why it's very convenient to familiarize the sequence operations, because you will be able to utilize them amongst sequences in Python. And that includes string, that includes tuples, lists, and range objects as well to some extent. So there are limitations. Okay, next operation is membership. So let's go back to our my list example. And I could check whether 10 is a member. So whether 10 is a member, okay, using in operator. This is a Python operator keyword. So 10 in my list, and it's a boolean, so it will tell you whether, okay, 10 is an element of your particular sequence. So in this case, 3.2462426, and you have name and you have true. Okay, and what we are expecting here is this is true, because indeed 10 is an element there. Okay, if I say 11, then it is false. Is it an element of my list? And this should be true. Okay, because you have true here as your element. If we try say name, this should be true. But this is case sensitive. So remember that this is case sensitive. So if I try to misspell in my name or change it to smaller case, then this will become false. Okay, but if I change it to the first letter being capital, this should be true. Okay, so that's membership. So membership will check whether that particular object is indeed an element of that particular sequence. So you will use the in keyword in Python. This is very convenient. Like if you're using this with alongside if condition, and this is the condition. Like if name is in my list, okay, then do this particular operation. And perhaps this is what we utilize in range as well, like for I in range. So if you notice, we are also utilizing the membership operation here. Okay, and then we do something like printing something. Okay, and if you notice, this in is a membership operator. It will give you truth if indeed it is a member. Otherwise, it will give you false. Okay, concatenation. So let's go back to our my list. Okay, and what if I want to add something, some new elements? So I could use the plus operator for concatenation, and I could add maybe more numbers. Okay, like 1, 2, 3, 4, 5. So the result will be just the combination of the elements. So if I check now the length of these items, so if I save this to my new list, so this is my new list. Okay, and check the length of your new list. Okay, then the new list is already bigger. So you have 9 elements. Initially, you have 4 elements added with 5 elements, and you have now 9 elements. Pretty much that's the meaning of concatenation. So you could also do this with uh, tuples and strings. Okay, but for range, you cannot do this with a range. So like if you have range 5, I cannot. I think I cannot use the plus operator here because you are adding object, and this is a vague operation. So the concatenation is not supported to range. Okay, but you could do this with the other sequences like list, tuples, and strings. Okay, so that's concatenation. You're just combining the elements. Okay, like if you have a string, like Sherlock, okay, is the other string, and you will simply combine it with a blank and combine it with Holmes, and in that case it will be a full string. So this operation is concatenation, and you could use this for the most common sequences: list, tuples, and of course the string, and so on. So these are basic sequence operations. You could also check the length as what we have stated earlier. So in this case, if I have, okay, let's just stick with our my list earlier. So my list, okay, the length here is 4, and that's what you expect. That is what you will get, okay, which is 4. Not much to that operation. It's just measures the size. You could always ask for help if you like to investigate the documentation. So it's return the number of items in a container. Okay, iteration. So for I in the particular, so this is for in pattern. So you have for items in my list. So print the items. Okay, and you have the elements of your list. So you have 10, you have 3.2426, you have the string name, you have the boolean true. So I could play with this. I could play with this for loop. So you could just say print the items together with their data types. So I will also print the type. Type is type of that particular item. Okay, or this should be item. I already declared it as items, so let's just go with it. Okay, and you could see that for 10 it is an integer, for 3.2426 is a float, for the name it's a string, and finally for the boolean, for the true it's boolean. Okay, so that's the for in iteration. You could also do summation, but this is only limited to numbers, I believe. Okay, if we perform sum, okay, to my list, I will be surprised if it computes something. So there's an unsupported error because you have a float and a string. So what if I have a list of numbers? Okay, so a list of numbers, maybe there is 1, there's an floating point number 2426, there's another integer, another floating point, okay, and one more integer, so 8. So okay, given these numbers, if I will issue the command sum, it should give me the result, which is 35.33826. So with numbers, it doesn't have any. It did a character in our result. Take note, if you enclose it with a bracket notation, even if it's a digit, it is no longer an integer. It is already a string. So if I issue the command for sum, okay, it will give me an error now. And simple reason for that is among the elements of your sequence there is a string, and you cannot compute the sum of a string together with a float or any number like integer. Okay, but if we delete that again, this should work fine, and it will give you the result. Okay, so submission is limited to numbers. So in that case, the numbers such as int and float. Okay, you could also, it supports unpacking as well. So unpacking simply means, okay, if you go back to my list, if you're going to assign the elements of your sequence to a variable or to variables in this case. So since you have four values here, I could have four variables like A, B, C, and D, and I will unpack my list. Okay, I will save the elements of my list to individual variables. So this is what we call as unpacking. Okay, we're trying to unpack. So naturally, what do you expect here? Since we're unpacking the list, and this is the content of your list, so you expect 10, okay, to go to A. So A now will become 10, and 3.2426 will be stored to B. And for the C, it will store the string. So it will become your name. And for D, okay, it will give you true, being the Boolean. So in that case, we could print the values afterwards for us to verify this unpacking operation. So if you print A, it will give you 10. If you print B, it will give you 3.2426. And C will give you name. And D will give you true. Okay? So that's the operation of unpacking. One subtlety about unpacking is if you try to unpack the variables and then you have less number of variables on the left side. So in that case, it will give you too many values to unpack. That means the interpreter is confused where to put the extra values, because in your list you have four values and you are just assigning it to three variables. So one way to get about this is you're going to use an arbitrary star operator. So to tell the compiler that, or to tell the interpreter in this case, just put an arbitrary number of elements there. So in this particular notation, so you have the first number or first character will take in the first element. So this will be the first element. Okay, and then D will take in the last element. And what will happen to this star means arbitrary value. So the arbitrary elements in between will be saved to the B variable. Okay, so if we have 10 as your first value after this operation, A will give or will save the 10, which is the first value, and D will save the true, which is the last value, and B will save everything in the middle. Okay, which is B will become a list. So if you check the type of B, okay, the type of B is actually a list. So that's an arbitrary, if you want to input arbitrary elements. Okay, so you could just try to use two variables. So as you might have guessed, let's print the my list first. Okay, just to recall the values. Okay, and then let's try to save the first element to A and the rest, okay, to B. So in this case, this particular unpacking will save the first element, which is A, uh, or the first element, which is 10, will be saved to A, and the rest of the elements, okay, will be a list 3.2426. Then the name, they will all be saved in B. So that's how it works. The rest, okay, if you use the star symbol or asterisk. Okay, so let's try to print this and print A, print B, and check the type of B, okay, which is a list. Okay, so that's unpacking, basic unpacking. Another sequence operation is repetition. So if you have my list, where's my list? Okay, I forgot to use underscore. Okay, my list could be repeated. The repetition operator could be using the asterisk operator again. So my list times, if I want to repeat it twice, so I will just use times 2. So as you could see, it became a bigger list with duplicates. So there's 210. Okay, there's two names, two tens, two names, and two true. So it will basically repeat. So just like a string, okay, if I have a string, say hello, if you use the repetition of a sequence, maybe times 3, so it will simply repeat that particular string. And this is a very convenient operation to a sequence. So you could easily repeat a sequence by using the multiplication operator, but this is overloaded. This is not multiplying anything, this is just repeating. Okay, repetition. And lastly, you could sort. So if I have elements, maybe letters, okay, and I will have a list, okay, which is B, okay, let me randomize it a bit, A, and C, for example. So if I want to sort it in increasing order, so that is A, B, C, D, or A, B, C in this case, I could just say sorted and letters. This is a built-in function to sort a sequence. The same with numbers. So I could say, do you have my numbers earlier? So my numbers, okay, or simply numbers. There. So I could sort this. 20 is the largest, so it should be the last. So if I'm going to sort these values for my numbers, I would expect to have 1, 3.14, okay, 3.2426, followed by 8, and followed by 20. So that's what I expect. You could easily do this in Python using sorted. So sorted and then numbers. Okay, and indeed it sorted from the smallest to the largest. Okay, and pretty much that's it. So that's how to demonstrate the these basic operations which you could perform on any sequence. So these operations, let me emphasize it once again. Indexing, slicing, membership, concatenation, okay, length, iteration, summation, Again, this is limited to numbers. Okay, so perhaps not this. Unpacking, repetition, and sorting. You could perform this to a list. You could perform this to a tuple and also a string. Okay, so these are sequences. And to a limited extent to range objects as well, in which we are going to investigate later. Okay, so what is a tuple? So this is very similar data structure to a list. The only main difference that I could think of is the tuple is not changeable. So once you declare the tuple, you can no longer change the elements. So if you remember, if we go back to our list earlier, so let's go back to our my list and then let's compare. So if I have my list, okay, and let's say that I want to replace 10. So the first element will be replaced with, say, I want to replace it with 20. Okay, I can easily do that. And my list will be modified. So list supports assignment. So you could do assignment, you could change the values. Okay, while tuples does not. So it does not support assignment. Okay, let's give an example. So the way I declare a tuple is I usually use a parenthesis operator, although it's not required. So let's say this is my tuple, and I will intentionally use the same values here. Okay, so these are same values. Okay, so 10, 3.2426, name, and true. So I could store that without any problems. But if I decide now to change the first element, so in my tuple, okay, I decided to change the first element. Okay, I want to make it 20. Remember that in the list, okay, we could easily do this. So my list, the first element, we change it to 20. Okay, but if I have a tuple, then this will give me an error. So tuple object does not support item assignment. And the main reason for this is because the property of a tuple is it is immutable. You cannot change it once you have declared a tuple. Okay? So if you want to change the elements of your data, do not use a tuple. Use a list instead. Okay, or the other data structures in the future, which we are going to investigate. So heterogeneous container of elements. So it's the same with the list. You could contain different items in a tuple. A tuple could also contain another list. So if I would decide to store a list, okay, like in my tuple, where is my tuple? Okay, my tuple. So for example, I have, okay, 10, 3.24. Okay, I have name, and I have another list. Okay, so say 1, 2, 3. Okay, this is perfectly fine with the tuple. So without any issues. Okay, because it contains heterogeneous container or heterogeneous data. So for a tuple, okay, let's demonstrate all of the sequence operations for a tuple. So you could index. Okay, so although a tuple does not support assignment, it it has index for the particular elements. Indexing being supporting the order. So if I have my tuple, okay, I have a first element. So this is my tuple, and indexing, I could say I could call the first element. Okay, I could call the last element through negative indexing. I could call the middle element. So 0, 1, 2, 3, 4. So the middle element is a 2, which is the name, and so on. So I could call the elements using an index. In the same manner, you cannot go beyond the number of elements. So if you have 0, 1, 2, 3, 4. So if you use 4, okay, so 0, 1, 2, 3, 4, you could still have the last element. But if you want to move farther than that, so to 5, there will be an index out of range error. So in that case, index error was encountered. This is the same with the list. Okay, you could just access the elements in a list or in a tuple using the index. Okay, using the index of that particular element. Okay, you could also use negative indexing. So if I want to print the first element using negative indexing, so I will count -1, -2, -3, -4, and -5. So -5 will print the first element, which is 10. Okay, and indeed it does. Okay, so next operation for our tuple is the slicing. So if we go back to our my tuple, okay, so I could slice the first three elements. Remember that for the slicing, it is exclusive. So if I have my tuple, so I could start with the first element, which is the default. So you could delete that part up to name. Okay, but if I want to include name, so this is 0, 1, 2, I need to move one step farther. So 0, 1, 2, 3, 4. So if this is 0 to 4, okay, I will expect this to give me 10, 3.2426, and name. Okay, 0 to 4. Remember that the fourth one, which is the true, okay, this is not included because the range in slicing is exclusive. That means it doesn't include the upper end exclusive. Okay, so let's see if indeed we got what we expect. So we expect a tuple up to 9. So okay, there's just wrong spelling in this case. So tuple up to, okay, up to, in this case, 0 to 4, 0, 1, 2, 3. Okay, so 0 to 4 earlier. Let's just review the indexes here. So this index 0, this is index 1, index 2, okay, and this is index 3, and this is index 4. So I'm using I'm printing actually 0 up to true. Okay, if I would like to print up to name only, then I need to issue up to 3. Okay, so that's what I'm expecting earlier. So 0 to 3. Okay, so let's review this part just to be clear. So if I want to print, okay, maybe just the middle two, okay, maybe the name and true, I will take note of the indices. So 0, 1, and 2, and 3, and 4. So what I will do is I will simply print, okay, my tuple, okay, from 2 up to, if I use up to 3, okay, remember that this is exclusive. So it will only print the name. Okay, so for me to include true, okay, I will extend up to 4. Okay, so that's what I will do. So remember that I expect to print name and true. So my slicing will be, okay, my tuple, and let's just slice it from 0, 1, 2 up to, so 2, 3 up to 4, exclusive. So again, what I expect here is name and true. And indeed, it is name and true. Okay, if I expect true and then the list, so I could just say from 3 onwards. Okay, and in that case, I printed the true and then the list. If I want to print, say, the first element of the list, okay, I want to print 1. Okay, then in that case, this will be double, okay, 2 levels of indexing. So I will call first the 0, 1, 2, 3, 4, fourth element. And within that fourth element, this is a list. So I will index the first element. So this will give me 1. If I want to get the second element of the list, this will give me our second element is 1. This will give me 2. And finally, the third element of the list, okay, the third element is actually 2. So if you input 3, that will be out of range because the minor indices here is just 0, 1, and 2. Okay, 3 is out of range. So that's out of range here. Okay, so I hope that's clear. The indexing is clear. So we could review the slicing with another example. Say, let's just say another tuple. Okay, in this another tuple we have, okay, just if I will initialize this with just a list of numbers 1, 2, 3, 4, and 5. Okay, so I want to slice 3 to 5. So another tuple, so 3 to 5 will be 0, 1, 2. So 2 onwards. Okay, another tuple. Okay, so that will be 3, 4, 5. If I want to slice 2 to 3, so I will be just 1, 2 to 3. So 0, 1, 2. And this will be 2 and 3. If I want to reverse, okay, we could use the magic. Okay, -1, reverse the elements. So it will be 5, 4, 3, 2, 1. Okay, although it's no longer slicing in this case. This is just reversing. Okay, so slicing works in a tuple the same with the list. So you could also have membership. Okay, like in my tuple. So whether name is there, okay, name is in my tuple, okay, the string. In this case, this is true. And if you convert it to small, this is false because Python is case sensitive. Okay, if you put investigate whether 10 is in the list or is in the tuple, okay, that's true. And 11 is not, and so on. So you could also check whether it's a list. So whether 1, 2, 3 is in the tuple, and this is supposed to be true. Okay, but if you add one more element like 4, okay, that's already false. Okay, so pretty much that's it for the membership. Concatenation, so the same with the list, you could also concatenate tuples. So this is an existing tuple, so I will add something new. Maybe a list of maybe some drinks. Okay, so all of them are string, for example. Okay, just two. And if I check the result, so it will simply combine the result. So the plus here will be an overloaded operation, and this simply means concatenation. Okay, very convenient if you're trying to combine multiple tuples. So after concatenation, you have also checking the length. Okay, like the length of my tuple. So this is a method or a function. Okay, length of my tuple. And in that case, it will simply count the number of elements. Remember that if you concatenate it like this, okay, my tuple plus latte and t, it doesn't save it in a variable, so it does not override your my tuple. If you really want to override your tuple, okay, you could assign the result to a new variable, and okay, that result will be the combined, and it's already 7 elements. And if you print the new tuple, okay, it contains already all of the elements. So if you want to add or combine tuples, you need to save it to a variable for you to be able to utilize that combination of values. Okay, so you have also iteration, like in my new tuple. Okay, let me check my new tuple. Okay, you could iterate through all the elements. So for item in the new tuple, you could print the items, and it will individually print the elements. So first element you have 10, 3.24, name, true, 1, 2, 3, okay, latte, and T. Very similar. So this is the same as the list, only that the tuple is immutable. You cannot change it, and it stores smaller. The memory footprint is slightly smaller than the list, okay, because it is immutable. You could also do unpacking, okay, of a tuple. My original tuple was or has 5 elements. So if I want to unpack these elements to variables like A, B, C, D, E, I could easily do that and assign the result, okay, to these variables. So if I print A, it should contain the first element, like 10. If I print B, it should contain the second, and so on. So C, name, and then D will be the true, and E will be the list. Okay, so in fact, you could check the data type. Okay, and that is a list. So that's unpacking. So you could also use what I showed earlier, like arbitrary parameters. Okay, like if I have an A and then I have, let me just have an arbitrary X and the last element. So maybe the last. So let me just call this first, last. And you assign the my tuple. So the first will be 10. This will be the first element in the tuple. The last was the list, if you recall, and everything in the middle will become a list. So if you print the type of the X, it's already a list, and if you print the values, it will be the arbitrary elements in the middle, like 3.2426 name and true. So that's unpacking for you. Okay. Uh, Tuple also support repetition. So just like before in the list, okay, if you multiply my tuple with a certain value like 2, it will double your tuple. Okay, the elements will be duplicated, and the length of this will be times 2 of the original. So from 5, okay, the length of your tuple will become 10 in this case. So that's repetition. Okay, sorting. Tuple also supports sorting. Okay, like if I have a tuple of letters, so say let me have A, B, C, D. It's already sorted. So let me randomize it a bit. So R, F, G, H, O, uh, A, and X. Something like this. So by the way, although when you declare a tuple, you usually use a parenthesis is not really required for you to declare a tuple. So in this case, if I declare these characters as a tuple, so let me just clear this up. Let me declare it as characters. Okay, so it will not give a problem. Okay, and then if you check the type, letters. Okay, and it's the by default it is already saved as tuples. So I could simply sort this, okay, using sorted and then letters. Okay, and as you could see, it's sorted in alphabetical order. So this is the same with numbers. So if I will come up with a tuple of numbers and say I have 1, 2, 3, 4, or let's randomize this a bit. So 6, 5. Okay. So if we sort this one, okay, you will come up with sorted numbers, although 6 is repeated. But you could see that the order is already increasing. And I think the data type here is already a list. So if you type, if you check the type, yes, indeed, it is already a list after sorting the values. Okay, because remember that a tuple is immutable. So the result after sorting it will no longer be a tuple in this case. Okay, so for the next drill, okay, I encourage you to also investigate these operations to arrange object. So whether you could index arrange, whether you could slice, or you could check the membership, you could concatenate. So we have done it earlier, okay, that this is not possible. We have already indicated it earlier. So feel free to investigate. This will be very helpful for you to manipulate sequences. Okay, so once that's done, maybe you have already discovered, okay, that although some of these operations are possible in a range object, then not all, but not all of them can be performed. So indexing, if you have a range, say 5, I could have, if you recall that the sequence here is 0 to 4. So 0, 1, 2, 3, 4. So this will be my first element, and this will be my last element. So if I want to print the last element using negative indexing, like negative 1, as you could see, indexing is fine with the range object. So there's no problem with indexing. I could print the first element, which is 0. I could print the middle element, maybe 0, 1, 2, something like 2, and so on. So indexing is fine. It works fine. Okay, even the negative indexing didn't give me a problem at all. So indexing will work with a range object. How about slicing? So if I have upper to lower, like I want to slice the first two elements, so 0 and 1. Okay, so it merely returns 0 to 2. Okay, but it did not give me an error. So it still works. If you want the sequence, so you could just convert it into a list, and you will be able to see the sequence like 0 to 1, 0, 1. Okay, but still it works. So if I slice it from second element onwards, and it works 2 to 5. Of course, to visualize the elements, you could just convert it into a list or a tuple if you like. So 2, 3, 4. So with respect to this operate in membership, so if we check for membership, okay, like whether 4, okay, whether 4 is in this range, 4 is in the range object, okay, range up to 5. So this number, recall that this number is 0, 1, 2, 3, 4. So 4 should be true. 4 should be a member. And indeed it is. However, 5 is no longer a member because we started from 0. So this should be false. And indeed it's false. Okay, so membership works fine with the range object. How about concatenation? So we have seen it before that if you would like to concatenate, so range 5 plus, say, range maybe 2, okay, unsupported. So in this case, we cannot perform concatenation. Well, if you force it, you could convert them into list and concatenate from that. So if you really want to force the issue, so this should be a list. Okay, although this makes no sense, but the idea is, okay, you could, okay, some could do something like this. Okay, so in that case, it's concatenated. But again, this makes no sense. Why not begin with a longer range to begin with? Anyway, that's possible. But range objects, you cannot concatenate them directly. Okay, you could also check the length, I believe. So, okay, if you say the length of range, say 5, okay, we'll give you 5. No issues at all. So 6, will also give you 6. But again, the numbers here started from 0. So 0, 1, 2, 3, 4, 5. And that's 6 numbers. So for iteration, well, this is the okay, this is the basic format for iteration, right? So for I in range, so it does support iteration. So remember that, okay, we usually do this in our operation. So iteration is fine with range object. Summation, can you do a summation for the range? Okay, let's try. So sum, and it does give us a result. So whether it's correct, so it's 0 plus 1 plus 2 plus 3 and plus 4, and it is correct. So 6 plus 4 is 10. Okay, so summation is correct. Unpacking, does it support unpacking? So if we have A, B, C, D, E, okay, can we assign the range object for that? And well, it does. Okay, it does support the unpacking of values. Okay, you could also do the arbitrary element. So in B is 1, 2, 3, so A is 0, and E will be 4. Okay, so arbitrary elements is also supported, and unpacking in general. Repetition, so you have range of 4, for example, and then times 2. Okay, repetition is not directly supported. So you need to convert it into other sequences. And sorted, mm, okay, let's try sorting. Although if it's increasing, it's already sorted. So let's try the decreasing value. Okay, like 10 to 0, and then decreasing value. Okay, sorted, and it should produce 1 to 10, and it does. So range sorting is supported. So just to summarize a bit, okay, what operations can you do with a range object with respect to the sequence operations? You could do indexing, you could do slicing, membership, concatenation. You cannot do this directly. Okay, for the length, you could do it. Iteration, okay, summation, you could do it. Unpacking, you could do it. Repetition, not. So sorting, you can. So for the repetition and concatenation, it's not directly supported. Okay, and it makes no sense, or it makes sense. Okay, that these operations are supported, because if you concatenate, it will be somewhat confusing to the interpreter, along with repetitions as well. Okay, so that's the operations for your range object. Okay, in the next parts, okay, we are going to proceed with the string. So string here with respect to the sequence operations. Okay, like indexing. So if I have, for example, name, okay, which is, for example, angel, okay, and you have particular index. So you could say that the first first letter is A, and the last letter will be, okay, the last letter is L. So name minus 1. Okay, and it does support indices, even the negative index. So negative 1, 2, 3, 4, 5. So I will print A using the negative index, and that will be negative 5. So a string is a sequence of characters. So that simply means that A and G, E, L, okay, will have their own designated index like 0, 1, and 2, and 3, and 4. So with those designated indices, you could try to print them or access them. But I believe this is immutable object. String is also an immutable object. The same with the tuple. So you could doesn't support assignment. So if I want to change A to B, so first element, if I want to replace it with a letter, another letter, then it will tell me that it doesn't support assignment. So because this is immutable. Okay, the same with the tuple. So just to recall it a bit, when we declare a list, we usually use the bracket notation. When we declared a tuple, okay, we usually use the parenthesis notation, although we can do without it. We could just use the comma separated values. It will give you the tuple. And for the string, okay, we usually use the either the double quote or the single quote or the triple quotes for multiple lines. Okay, triple quote for the multiple line string or the triple double quote. So you could also use that. So it does support indexing. You could index the string, but can you slice it? Okay, like for example, if I want just to print the first three letters. So the first three letters in the name, okay, will be from 0, okay, up to 0, 1, 2. So I cannot use 2 here because it's exclusive. So for me to print the first three letters, I will extend up to 0, 1, 2, 3. Okay, remember that the third element here is E. So let's just clarify this a bit. So this is 0, 1, 2, 3, and 4. So if I want to print these first three letters, okay, then I need to extend my slice 0 up to 3 because 3 here is exclusive. The meaning being you are not including it exclusive. The upper limit is exclusive. So this will be A and G. And if I try to remove the 0, this would still work because the default is 0. And I could print the rest of the letters using 3 onwards and so on. So that's the slicing here works. You could also try to reverse the character, okay, with the negative 1 trick. Okay, so that's just negative reversing the iteration. So the string will be reversed in this case. Okay, you could check membership. So but this membership will be either a character or a string membership. So like for example, located in the name, and that's true. Whether B is there, okay, that is false. Okay, you could also combine a sequence, a substring like an. Okay, is an there? True. Okay, ang is also present. Okay, but if you have to make a wrong sequence like angi, this will become false already. So the first three operations, you have the indexing, slicing, membership are all supported. So how about the next operation? Okay, like concatenation. So you might have seen this in the orientation, the first meeting. That yes, you could concatenate strings. Okay, like you could say you could concatenate a space. Okay, you could say, for example, falling. Okay, so in this case, it became convoluted. So let's close this, and this will be the new string, the combined string. So the new string, okay, which we could print, okay, as a fallen angel in this case. It's just combination of the existing. Okay, in fact, you could also print this, and if you notice the default separator in your print function is space. So you by default you will have space. Okay, so fallen angel. Well, if you want to investigate that further, you could just ask for help in this case and print. So the default separator here is space. Okay, so concatenation, you could also check the length. So in my name, the length here is 1, 2, 3, 4, 5. Okay, so you have 5 characters as the length of my name. And in my new string, okay, remember that the blank character is also a character, so that will be included in the count. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this will be the length here will be 12, including of course the space character. So new string, okay, that's the length is 12. Another operation for the sequence is iteration. So you could print the letters in the string. So for letter in the name, okay, you could print the letter, and you printed each of the letters. So index 0, index 1, 2, 3, 4. Okay, you could also remember that the summation is just limited to integers. So in this case, if you perform the sum of the name, okay, unsupported operation. So just to recap a bit, in the string, indexing is supported, slicing as well, membership, concatenation, length, iteration, but not summation because this is a string. Okay, so the last operations, you have the unpacking. Okay, so if you have first letter, okay, and then let's print the name. Okay, so I will unpack my characters 1, 2, 3, 4, 5. So A, B, C, D, E. So unpack the name to those variables. And it does support it. So variable A is now capital A, and D will be N, C will be G, and D will be E, and E will be L. So this is supported, and you could also try to sort. So sorted name, and it will just arrange it. Remember that capital letters have smaller ASCII value, so it will be sorted first. Okay, and then after that the small letters, so E, G, and L and N, and finally that's it. So for the string, okay, as a summary, so this is supported: indexing, slicing, membership, concatenation, length, iteration, but not the summation. So you could also unpack, you could also repeat, you could also sort. So let me show the repeat. Okay, maybe we haven't shown it. Okay, but don't worry, we will repeat. Uh, we will solve the patterns using string repetition later on. So if we have a name, okay, and we need to repeat it maybe 10 times. Okay, so in that case, you could easily do that in Python using the repetition operator, which is the overloaded multiplication operator. Okay, so repetition, that's repetition for you. That's very convenient later on. So pretty much that's it. So in the next drills, okay, we're going to use the string repetition pattern to solve the the Python patterns that we have already demonstrated in the second refresher video. So using what you have learned, try to come up with the solution to these drills. Okay, without using a nested for loop. So we will simply be using a single for loop in this particular solutions. Okay, with the knowledge of string repetition. Okay, so we are going to utilize the old function that we have created in the second video. So the function is taking a random character. Okay, so this is just taking a random ASCII uppercase character. Okay, and after that, okay, this put character will simply return a simple ASCII character. And since we are trying to come up with a parameters to the function, maybe we could declare the the height and then the width of the box as input parameters to the function. Okay, so that would be something new. Okay, so use Python sequence operation. We could add use height and width. Okay, height and or width, or this and width as function parameters. Okay, function input parameters. So this is, we could easily do this by putting the variable within the parentheses. So let's try the box. Okay, in this case, this is an example, 50 by 5 box. So your code here, let me define my box, and input parameters being the height or the width and height. Okay, and okay, this particular function, okay, prints a box pattern. Okay, prints a box pattern. So in this case, with a certain width and height. So if we could use the string repetition that we have learned earlier, then we could reduce the nesting, or we could do away with the nesting of the for loop. So I could just say for row in particular range, okay, with respect to the height, and I will simply print the character, okay, which is taken randomly here from refresher to video, and then multiply it with the width, okay, with the repetition. And I believe pretty much this is it. So I have 50 by 5 box. So I could just say width 50 and height is 5. So this is my function call with parameters. So control, let's run this. I'm expecting to see a box. Okay, but the box is not that well presented, so I need to print something beforehand. Okay, and now this looks good. So what's happening? What's going on here? The idea is when you call the function, the box. Okay, this input argument like 50 will be passed to the parameter width. So width will will have a value of 50. And the second argument, so the order matters here. The second argument, which is 5, this will be passed to the height. So height will have a value here of 5. So that's why you have input parameters. And you don't need, within the function, as you could see, I don't need to provide values for the height and the width, because this parameter is expecting something from the user, expecting an argument from the user. Like the user should provide 50 and 5 argument. Because if the user does not provide numbers, this will be an error. Okay, box missing 2 required positional arguments. So the error here is very informative, that the interpreter is expecting you to provide the width and the height arguments. So that's why we could provide the width and then the height arguments. Okay, like this one, 40 by 10 in this case. And if we run this, okay, we can get this one, okay, which is a nice box pattern. So if you recall before, we have already solved this, but the solution was nested for loop. Okay, however, using repetition in Python, okay, the repetition, we were able to reduce it or to flatten it out into just a single for loop. Okay, which is very easy to read as well. So you're just repeating it with respect to the width. Okay, so in this case, okay, we could proceed with the next drill. So for the next drill, so you have here a hollow box. Okay, let's also use the pattern. Use okay, use the height and the width as function parameters. So again, please pause the video and try this drill yourself. So in this case, just use the sequence. Okay, so if you're trying to solve this, let me provide my solution as well. So I will just base my solution from the existing. And let me just name it hollow box. Okay, prints the hollow box. So the hollow box pattern, okay, using the this one, will simply have an if else. So if you notice that with respect to the row, okay, this is in this case, okay, this is row 0, row 1, row 2, row 3, row 4, and row 9. So for row 9, 0, and 9, I'm going to complete the line. Okay, however, for the rest in between, I will simply print blank spaces along with the letter. Okay, so I could just say mm, okay, if row is greater than 0 and it's less than okay, the height minus 1, okay, this is less than 9, then I will print the letter. So I will put a character, and after printing the letter, I will print some blank spaces. Okay, and repeat the blank spaces with how many? So this should be height minus 2 or width minus 2. Okay, and finally, you put the character. Okay, otherwise, you will simply do print the full character with. Okay, so let's try this one. Let's try a 40 by 5 box. So 40 by 5. Okay, let's run this. And indeed, it provided the result that we wanted. So you have one. Okay, so very simple. Only that in this case, this is no longer randomized, but that's okay. So this is just similar to what is provided. Okay, so we could proceed with the next one. And this one is the triangle pattern. So write a triangle with a height parameter. So you could use the height as function input parameter. Use height as function input parameter. Okay. So okay, I will name this okay right triangle. So so this is right triangle. And let me just call this the pattern looks to me like an L pattern. So an L pattern. And in this case, we are just required to provide the height, prints a, okay, prints right triangle with L like pattern. Okay, so same drill. Okay, let me have the initial print and 4 rows in my range. Okay, for the height. Okay, for all of those rows, I will simply print. Okay, I could start with 1 here. Or you could just say you are going to put character, multiply it with character, and for the second row there will be second or 2 character repetitions, and so on. With a height of okay just 5. Okay, 1, 2, 3, 4, 5, and that's it. So that's how simple it is. Okay, next drill. Okay, can you make this triangle a hollow triangle? So the L-like pattern to be hollow. Okay, so let's just utilize the existing, and let me just make this a hollow right triangle at a particular height. So prints hollow right triangle with L-like pattern. So to make this hollow, mm, okay, we could use a simple if else here. Um, so if okay, so this one has height 0, height 1, and height 2. So you could say when row is greater than 1 and should be row okay less than height minus 1. Okay, this one. Okay, you should put a sort of a blank space there. Okay, so greater than 1. So if the particular row is greater than 1 and okay less than height minus 1, okay, then what I would print is a random character, okay, plus a blank, okay, multiplied by or repeated by, it could be the number of rows minus something. Okay, the number of rows, okay, maybe minus minus 1. Okay, let's just try and experiment on this. Okay, otherwise, okay, you print the character. And let me, okay, let me issue it for, okay, for a height of maybe 5. Okay, so let's clear the output. Let's run it. Okay, well, okay, should be, okay, 5, 1, 2, 3, 4, 5. So this should be row is less than, okay, so this, the row will extend from 1. Okay, so this is 1, 2. So greater than 1, 1, 2. Okay, and this should be less than the height. Okay, and this should be greater than 2. Okay, so 1, 2, and let's subtract it with 2. Okay, just readjusting. So 1, 2, 3, 4, 5. Nice. So this looks good now. Okay, let's make it larger. So if it's 10, okay, and I believe this is what we wanted already. So this should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, nice. So the confusion earlier was due to the row convention, because I'm using the row convention now of 1 by virtue of this, and this is 2, 3, okay, up to the last element is 10. So that should reflect my if condition here. So this should be, this coverage here is actually within row greater than 2 and row less than the height. Okay, so depends on you. If you would like to modify this or you retain the 0, okay, then there will be changes here in the if else condition. Okay, but that works for a problem in this case. Okay, so next problem. So as you can see, the solutions that we came up with is very simple, and we did not resort to nested for loops. Okay, unlike before in the previous video. Okay, so write a Python program that prints the following inverted triangle pattern. So you also use, okay, use height parameter. Well, in this case, this is inverted L. Okay, so Again, please try this yourselves as well. And if you're done, then let's solve it together. So uh, in this case, this is not the hollow triangle. This, I will just follow the right triangle earlier. So this will be the inverted right triangle. Let me just put inverted here. So inverted L. Mm, if I'm doing an inverted L, ah, I could use reverse. So I could just reverse this one. And so from instead of from 1 to 10, it's going to be from 10 to 1. And let's see if that works. Okay, height of 10. Okay, let's see. And let's run this. It works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, very simple. So just reverse the sequence from 1 to 10. You make it 10 to 1, and you came up with an inverted right triangle. Okay, so that's nice and all. So you could just say, how about the hollow version? Okay, again, you could post the video and try this drill. Write a Python program that prints the hollow inverted right triangle. Okay. So if you have done that already, okay. So let me just make this hollow inverted right triangle. So prints the hollow inverted right triangle L pattern. Mm, well, in this case, okay. So since we have inverted it already, so this will be 10, 9, okay, up to 1, 2 and 1. So for this condition, I'm going to limit the spaces. Okay, and that happens if the row is less than 10 and greater than greater than 2. Okay, so less than 10 and greater than 2. So if the row is less than mm, less than the height, okay, and the row is greater than 2, 1, 2, greater than 2, so that's 3 up to 9. Okay, then I'm going to print the character and print some blank spaces multiplied by, will it be the row, it should be row minus something. So row minus 2, okay, for 2 characters, and then plus put character. Okay, let's try if this works. Otherwise, just do the standard. So let's have a testing, which is, say, let's test it with 10, height of 10. Okay, and then let's run that. And it gave what we wanted immediately. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's that. So next drill, program prints the a parameter. Okay, use the height as a parameter. So following right triangle, so this is no longer the L pattern. Mm, what pattern should I call this? Okay, so anyway, okay, let's create the function. Maybe this is a right triangle. So I have already the inverted right triangle, hollow right triangle. Okay, so maybe I will just use the right triangle and then come up with a letter representation for this. So right triangle, and what letter should it be? No particular letter. Um, rotated L. Maybe just a rotated. Okay, right triangle rotated L. Right triangle with rotated L-like pattern. So for rows in the height, I will print the blank spaces. Print just the blank spaces multiplied by mm, so I could reverse the height. So I could just say 1, 2, height plus 1. So I could just say I will multiply this with height minus row. Okay, and then after that, let's print the character with respect to the row. Okay, so this might work. Okay, but we could always debug if it doesn't. So let's see with a height of 10. Okay, it works. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's it for our function. And we have another problem like uh, write a Python program that prints the following hollow right triangle pattern. So similar as before, hey, we could simply use an if else for this. So let's just again, you could post the video if you want to solve this, just to put challenge on yourself. Okay, so this is just a brief if else. So let me call this my hollow right triangle rotated L. So prints hollow. So for this hollow, mm, so you have a condition which is row is greater than 1, 2, greater than 2. Okay, so if row is greater than 2 and okay, row is less than the height. Okay, same condition as before. Okay, what do we print? So we print the character. Okay, put character plus we print a blank space, multiply that with row minus 2, and we put a character. Now, okay, let's see if this works. Otherwise, we print the normal. Okay, height of 10. Okay, clear the output first and let's run this. Okay, interesting. So it doesn't work in this. It works in the last one. Okay, so you have n and y. Wait. Okay, so put character. Okay, if row is greater than 2, so 0, 1, 2, we simply put character. Otherwise, we okay, so this times height. Okay, otherwise we simply put character times the row, so we will not put. Okay, wait. Okay, so otherwise we will still put a blank character. Okay, which is the same as before. Height minus row. So we will still put a space equivalent to height minus row. Then after what, we put the character, and then we put blank spaces, which is equivalent to row minus something. Okay, anyway, let's just run this one. Okay, and then it works. Okay, so this is the output that we wanted. So let's just check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay, so that's that. Next solution. Okay, the pyramid in this case. So pyramid. So the pyramid pattern is very similar, okay, to this one, to the problem number 2. So use height as a function. Okay, use height as a function parameter. And the same with the pyramid. We will use the height as a function parameter. And what I will do is I will just repurpose my solution here. And just utilize it with my pyramid solution. So this is pyramid. Okay, and prints the pyramid pattern. Or the triangle pattern. So currently, okay, let's observe what's the current output here. So the current output that we have, if say height is 5, hmm. Okay, so I will just extend the number of characters. Okay, we'll multiply it by, instead of row, this should be, so it's an odd number. So it's twice of the row. That should that should give me the pyramid and so if we're going to give it to height, so 1, 2, 3, 4, 5. Okay, this is what we wanted. So let's extend this to a height of 10. Nice. 10. Okay, height is 10. Okay, so that's what we wanted for the pyramid. Okay, for the next problem, okay, for the next problem here, if we're to write a function, hollow pyramid. Okay, so in this case, mm, we could simply repurpose. Okay, again, you could pause your screen and try this problem. So write a Python program that prints the hollow pyramid, and you use the height as a parameter in the function. Okay, so now that you have finished your code, so hopefully you could produce a hollow pyramid as well. So we could, in my case, I will just repurpose my previous pyramid code. So this will be now a hollow pyramid. So prints the pyramid pattern. So if I want the hollow pyramid, so it will simply be an if else. So if my h is greater than 0, or if row and row is less than the height minus 1, okay, so in this case I will change the printing to, okay, so there will be blank spaces. So print, I will put the character and concatenate it with put character and concatenate it with a blank. The question is how many blanks? So you have 1, you have 3, okay, 5, 1, 3, 5. So it's odd number. So odd number, which is 2 times row. Okay, you cannot say minus 1 because that will be it's minus something, so it could be minus 3. So let's try this. So hollow pyramid, let's try it with a height of 10. So if it doesn't work, let's just modify the subtractor, the subtrahend. Okay, it looks bad. So in this case, okay, there's no else. So else, okay, so it still looks bad. So you need, instead of putting character, you need to retain the spaces here. Okay. Minus, minus, minus 3 is extreme. So how about minus 2? Minus 1. So in the end, it's just the odd number. Okay. So now it works. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, nice. You could easily change this with a smaller value or a larger value. So now it's 5. So 1, 2, 3, 4, 5. Okay. So that's it for our hollow pyramid. Okay, we will also try it with our diamond pattern and the hollow diamond pattern. So for the diamond pattern, okay, again, we will use the h variable or h parameter as input. So the h variable denotes the height to center. So we could repurpose our, okay, we could repurpose our pyramid earlier. Okay, and let me just call this now diamond. Okay, again, if you would like to try this, so just pause the video and come up with your own code. And in this case, let me just call this diamond and print the diamond pattern. So we'll just have an upper diamond and lower diamond. So since this is just reversing, I will simply reverse the pattern for the lower. Okay, just reversing the sequence. And if we run this, okay, let's just call the function with a height of 5. Okay, this is not the total height, this is just height to center. Okay, looks good, but you have 1, 2, 3, 4, 5. So there are two centers here. So what I would do is I will reduce the second, okay, the lower layer. So I will just reduce the lower layer by making it, okay, 0 to range height. So reverse, so height minus 1. Okay, so hopefully this works well. And indeed, okay, it's the solution that we're looking for. So 1, 2, 3, 4, 5. And from the bottom, 1, 2, 3, 4, 5. Okay, so that's height to center, which is 5 in this case. So you could modify it to 6. Okay, so in that case, we'll have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Okay, so that's our diamond pattern, which is very simple. If you compare it to our solution with iteration, we had nested for loops in that case. But using the repetition of the sequence, or in this case a string, we easily came up with a very flat code for printing the diamond. Okay, so next, okay, this will be okay, second to the last problem for this particular refresher. So write a Python program that prints the following hollow diamond pattern. Mm, okay, so for this hollow diamond, we could just play with, okay, play with our previous code. So, okay, write a function that prints the hollow diamond. Use the h variable and make it a parameter of the function. What I will do is just say this is a hollow diamond now. Prints a hollow diamond pattern. And okay, put character. Okay, all we have to do is to include, instead of putting many characters, we could simply, okay, put one character, okay, and then add a blank, and then add another character. So this will be readjusted. So 2 row minus 1. Okay, so what happens if we do this? Okay, so let's call the hollow diamond, and let's call it with, say, a height of 5 to center. Okay, nice. Um, Not quite, because the first one and the last one has double characters. So we need to eliminate these double characters. Okay, so we could also multiply this character, okay, because this is the one that is, this character should not be added in the first and last. So this should be 0 on the first and last. And okay, that could be, the trick could be modulo here. So if you have 0, so this should be 1. Mm, we could come up with 1 modulo row. And in this case, let's test it for the first one. Okay, but if the row becomes 0, then that will be a problem. Okay, let's run this. This will be an error because you're dividing by 0. So we could start with the height with 1. Okay, just to avoid the zero division error. And in this case, okay, we need to adjust the spacing. So instead of -1, we could adjust it with -2. Okay. Mm, okay, so it looks better. How about -3? Okay, looks good. And what we will do for the second reversed part in, so we could have a range of, so instead of height -1, okay, 1 up to the height. Okay, so we have settled the upper part. Okay, 1 to height might be enough. And we will subtract these spaces as well. And voila. So we have solved the pattern. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, nice. So we could also modify the problem. So make it 6. Okay, so you have 1, 2, 3, 4, 5, 6. Nice. So that's the solution. Of course, this is not the only solution. You could modify solution. Some solution might involve multiple prints. Okay, like you could put this, the printing of the first and then the last outside the for loop. Okay, but in this case, we just opted to print it within the for loop using the modulo trick in this case. Okay, so for the last problem for this refresher, okay, again, feel free to pause your screen. So the problem is asking you to create a program about palindrome. So palindrome is a word, number, or a phrase in which reads the same backward as forward. So if you have a number like 108801, that is a palindrome. And like hello and uh, ole hello in that case. So this is a palindrome. If you read it from, okay, a common example in uh, words like you have Abba. So if you read Abba from left to right, you will get ABBA. And if you read it from right to left, you have ABBA. So this is an example of a palindrome. So in this case, okay, you're going to return a tuple. Okay, just return a tuple, accepts an integer or a string, and returns a tuple consisting of the two possible palindromes. That is the combination of the two. Okay, so accept a string or an integer. So you have two. So this could be an integer and this could be a string. So you could have a starter code here that it will generate the two possible palindromic sequence from the input sequence. So if it will only accept data types, which is a string or an integer. Okay, so this is the if else for that. So it is just telling you that if you inputted a data type that is neither a string nor an int, then this is a type error. The function will give you a type error. Otherwise, it will proceed. So I could just say input string, maybe input string or input sequence. So input sequence will be uh, so I could convert the string here. Okay, input string will be the string version of my sequence. Okay, and I could immediately return a tuple. Okay, so I could immediately return a tuple that is a combination. So of my forward. So I have a forward palindrome. Okay, and that forward palindrome will be input string concatenated with the input string inverted. So if you recalled earlier, this is how to invert the input string. Or I could have the reverse, and the reverse will be just the inverted string together with the input string. And then let's just print the forward and reverse palindromes. Okay, so if you say print, so hello, okay, just like what we have here in the example. So what I expect here, okay, if I print this, okay, then I expect to see this one. Okay, hello, Ole and Ole hello. Okay, and okay, it did give me the correct result. Okay, however, this solution does not work. So this works for a string. So this is already okay. Okay, however, if you try to input a number, okay, like 1, 2, 3, although it gives the palindrome, but the number was converted into a string. So in this case, we could we should not convert it, or we should convert it back to its original state or original type, which is an integer. So we could just say, okay, we could think of a test. So, like for example, if I have 1, 2, 3, okay, can I test whether it is a digit? Okay, this is true, right? So we could we could come up with a final test here. So this is the Okay, this is the conversion, or this is the output if you have a string. So you could just say if, say, if sequence, if input string, okay, if input string that is digit or is alpha, for example, is it alpha? Okay, so I could check whether it is an alphanumeric character. How about a combination? Okay, false. So this should be a string. But in this case, okay, well, let me just say that if it is not digit, is digit, else, okay, in this case, I will return, okay, the original integer versions. So let's just extend it, else I will return the integer versions. So what's going on here is, okay, if the input string, okay, this one was 1, 2, 3 or digits, or is digits, then I need to convert it to integer, typecast it to integer. Otherwise, I will just retain the output string. So that is one requirement of the system, because here it's number and it's not a string. The output is not a string, so the output is an integer. So if I issue the palindrome command to a 1, 2, 3, for example, the output that I expect here should be a tuple of integers, not a tuple of string. Okay, and let's run this. And if you check it, it's no longer a string. Okay, you could check the type if you like. So you could just say type of the output, which is the first element. Okay, it's already integer, and this is what we wanted in the output. So this is just a basic function that comes up with a palindrome with a distinction between integer and string. Okay, so let's test it again. Okay, with 5, 6, 7, and let's print the result for us to be able to see it. Okay, and indeed we got the expected output, which is 5, 6, 7, 7, 6, 5, and pretty much that's it. So we get the expected output, and we're able to distinguish between integer and a string. Okay, however, if you combine it, okay, if you combine the digit, it should be treated as a string. Okay, because if you combine it, you cannot convert it into an integer. So if you combine 5, 6, 7 AS, or mm, Okay, combine it with numbers. This is string to begin with. Okay, so this is string to begin with, and the output should be string. And if you inputted it as a string, it will be converted into a number. Okay, so this is because it is a digit, the input, or this one is a digit. Or in this case, if you input initially a string, it should be a string. Mm. So I could modify this code a bit. If this is my initial type, so the initial type is the type of the sequence. So if type is string, okay, or type is int, okay, if not type is if it is not a string or an integer, raise a type error. Okay, and then you only need to convert it if type is equals to int. So if init type is int, okay, then do the conversion. And then string sequence, or I could just say convert the sequence. I'll just use sequence. Okay, convert the sequence into its string, and then sequence, sequence, and then sequence, and then sequence. And then if init type, so forward if init type is str. Okay, else convert it to a string. So in this case, if I inputted 1, 2, 3, 4, 5 to begin with, if it is a string to begin with, the output should be a string because you inputted it to be string. But if you really meant it to be an integer, then you could use the previous code. Like you have to convert, if it is a digit, you have to convert it into an integer. Okay, that's just two ways of approaching the problem. Okay, so I could just include this in my testing, that if you input a string that is already, or a digit which is already a string, okay, the output should also be a string. Okay, which is quite tricky, but it's easy to solve. Okay, so something like this. And that concludes this refresher. So I hope you learned something, and see you again soon. Okay, thank you.